Let's start by understanding the key differences between narrow AI and general AI. These two concepts are fundamental to grasping how AI is shaping our world today and how it might influence future governance. First, narrow AI, also known as weak AI, refers to systems designed to perform specific tasks. Unlike humans, these systems cannot think or reason beyond what they are programmed to do. They excel at singular tasks, such as analyzing data, recognizing patterns, or making predictions, but they lack the broader ability to transfer knowledge across different domains. This is the form of AI that exists today and is already widely integrated across sectors like healthcare, finance, and governance. For instance, let's take facial recognition systems. These are used for security in airports and border control, and in some cases, like China's social credit system, to monitor citizens. Similarly, image recognition systems are also utilized. Ever noticed how Google Photos can recognize faces or objects in your pictures? That's narrow AI identifying and categorizing images based on patterns it's learned. Moreover, recommendation algorithms are employed by companies like Netflix, which suggests movies or shows based on your viewing history. In the realm of transportation, autonomous vehicles like Tesla's autopilot rely on narrow AI to navigate and avoid obstacles in real time. In our daily lives, virtual assistants like Siri and Alexa exemplify narrow AI, helping us with tasks like setting reminders or controlling smart home devices. But how does this relate to governance? Well, governments are already using narrow AI to improve public services and manage infrastructure. For example, the U.S. Internal Revenue Service (IRS) uses AI to detect tax fraud, while smart cities like Singapore use AI to optimize traffic flow. Now, let's transition to general AI. Unlike narrow AI, general AI, also known as strong AI, is still a theoretical concept. It represents the possibility of an AI that can perform any intellectual task that a human can do. Such systems would be able to understand, learn, and apply knowledge across various domains without needing extensive retraining. While it doesn't exist yet, its potential is a long-term goal within the AI research community. Imagine a general AI that not only runs a government but also drives advanced scientific research. When we think of general AI running a government, it could analyze vast datasets and make decisions based on real-time information, free from human biases, political pressures, or emotional influences. Therefore, it could potentially handle complex tasks in many fields, such as economic policy, social welfare, environmental policy, crisis management, or legislative and judicial oversight. It could autonomously lead breakthroughs in physics, biology, or chemistry, discovering new laws of nature or developing cures for diseases without human intervention. Now, picture that same AI piloting spacecraft, exploring distant planets, moons, or even asteroids, making real-time decisions and overcoming challenges in space exploration. AGI could also revolutionize education by acting as a personalized tutor for every student. It wouldn't just cover basic subjects like mathematics, but also adapt its teaching methods to each student's learning style, helping them master subjects across the board, even in areas like social skills and emotional intelligence. Think of an AGI tasked with urban planning. It could design and manage entire cities, optimizing everything from transportation and energy use to waste management, while ensuring the city remains environmentally sustainable and livable for its inhabitants. And finally, imagine a general AI involved in international diplomacy. It could mediate peace negotiations, resolve trade disputes, or even handle large-scale conflicts by understanding diverse perspectives, analyzing cultural, political, and historical contexts, and proposing solutions that foster fairness and peace. However, the introduction of general AI would raise profound questions for politicians. It could challenge traditional roles by advising on complex decisions with enormous consequences. The crucial question would be how to regulate and govern such technology. What if general AI starts making decisions autonomously? Who holds the power over these systems? These are debates future politicians must engage with. In addition to these functional differences, ethical concerns surrounding AI, both narrow and general, cannot be overlooked. Let's begin with narrow AI. Privacy issues arise when governments use technologies like facial recognition for surveillance, potentially infringing on personal freedoms. Similarly, job displacement is a growing concern as AI-powered automation replaces manual labor in industries like manufacturing. Another challenge is bias and discrimination. For example, Amazon's AI-based hiring system showed bias against female applicants because it was trained on skewed data. In the case of general AI, the ethical dilemmas intensify. Imagine a general AI system controlling a country's defense, deciding when and how to engage in warfare. This raises concerns about autonomy and control, as well as the potential for existential risk. If a highly intelligent general AI is not aligned with human values, it could make decisions that harm humanity. Politicians will need to play a vital role in ensuring that AI development is safe, transparent, and aligned with human ethics. Now, let's move on to the role of data, which is the fuel behind AI systems. Narrow AI relies heavily on vast datasets. For example, Google Translate uses a massive amount of multilingual text to improve its translation capabilities. However, if the data is biased, like in predictive policing systems, AI can reinforce societal inequalities. This places a responsibility on policymakers to ensure that AI systems are trained on fair and representative data, and that their algorithms are regularly reviewed for fairness. In contrast, general AI could potentially function with minimal data. A general AI system might need just a single example of how a political campaign works and then apply that knowledge to run campaigns across different countries. This ability raises important questions about data ownership and privacy. Who controls the data, and how much can an AI infer from limited information? These concerns will become even more pressing as AI systems grow more powerful. In conclusion, as politicians, it is essential to understand the differences between narrow AI and general AI, their applications, ethical challenges, and the critical role of data. This understanding will allow you to better navigate the emerging AI landscape and to craft policies that foster innovation while protecting society.